This slow simmer is evidence that in one spot in the Imperial Valley, there's more than what meets the eye. Even from a slight distance, you can hear the gurgling of muddy water, also known as mud pots and mud volcanoes. It's a familiar sound to many local residents of the Imperial Valley, but to others, it's something they never knew existed. Located about 15 minutes northwest of Calipatria near the southwest shore of the Salton Sea, lies one of the most unique natural wonders in the United States. We, too, were curious about this geological phenomenon. Kevin Marty, a geologist at Imperial Valley College, explains the science on how these mud volcanoes can grow taller than some people.
It's tied to, seismic and also volcanic activity. People were actually out here before and after the 2010 earthquake, the Easter Sunday one, and they noticed an increase in the gases that were emitted after the earthquake.
Marty says because of the unique nature of the fault lines in this area, the Earth's crust does not push against each other, but pulls apart instead, bringing us nearer to the Earth's insides.
Magma being generated relatively close to the surface, and so then that's affecting, it's heating the groundwater, heating the water beneath the surface and creating geothermal energy.
The presence of geothermal energy in the area is evident by the power plant that looms very near in the backdrop. A different kind of smoke seeps out of the mud volcanoes, however, and is often accompanied by bubbles.
Here you have the breakdown of the mud, the sediments, and then the CO2 rising.
Marty says carbon dioxide emission was once so high that it was farmed for use in dry ice production. As this sediment continues to build and mud dries, the volcano grows in size. Marty likens it to lava flowing from a volcano and then cooling, just on a much smaller scale.
How hot can this get?
Well, measurements out here have shown they've ranged between, say, 98 degrees Fahrenheit to 155, 160 degrees.
While some of these areas generate heat, many of the areas with standing water in them do not.
While this may have the appearance of a jacuzzi, there's actually no heat involved in it at all. The bubbles that you see are merely carbon dioxide rushing from underground and forcing through the surface. Areas such as this one with steam coming from them obviously have heat, and that's coming from underground as well as the carbon dioxide. But this one is unpredictable. As you can see, it's already gotten me. You can't set your watch to it. It really pops up. It's not like Old Faithful whatsoever, but it is very interesting to watch, and I can actually feel it from under me.
Even though we got pretty close to a few of these mud volcanoes, we did so with caution. The area is on private property, and the owner tells us people often ignore the no trespassing signs to explore, with some actually testing the temperature of the water and getting injured in the process. As a precaution, he asks that you let this be as close as you get to these mud volcanoes. It's pre-dawn. Colin Graham, a hot air balloon pilot, is up early and ready to launch.
We're looking for calm winds on the surface for the most part, and winds aloft that are going a direction that is favorable from where we might want to take off. And we have multiple launch sites around the area depending on which one of those is the best.
He sets loose a small balloon filled with helium to test which way the wind is blowing. On this day, the balloon floated to the north. As you can see, the balloon moves back and forth towards him, which indicates the winds are not strong in the upper atmosphere, which gives him a green light for liftoff. He then turns on the flames. The heat rises, and since it stays trapped inside of the balloon, it begins to work just like a helium balloon that we sent up to test the weather. But propane is the gas of choice here, and in this case, Colin fills the balloon with just enough hot air to keep it expanded, but grounded. Like a magic carpet, we begin to rise effortlessly, not a jolt of turbulence. Within seconds, we rise hundreds of feet above, where the skyline shows us a majestic view of the Yuma Valley. Our altitude is controlled in two ways.
Well, we control what's going on by burning, essentially. So if you want to go up, you burn more. If you want to go down, you burn less, or you can valve out of the top.
While a hot air balloon flies in the direction of the wind at ground level, given the right conditions, it can be navigated with near pinpoint accuracy. Colin lowered the balloon and took us for a dip in the Gila River, skimming the surface of the water with pure precision. During the hour-long ride, we reach altitudes of up to 1,500 feet, and I gotta tell you, the weather up here is cool and crisp. To land, Colin communicates with his field crew following from below. They identify a landing spot. Descending is trickier than taking off. To keep the balloon from free-falling, he carefully regulates the heat inside of the balloon and keeps a close watch on the altimeter that measures the altitude. This is important because it also allows Colin to gauge the direction of the wind to safely land the balloon. We continue to gradually descend, and within 10 minutes, we finally reach ground level, ending our hot air balloon ride. It's a wonderful fall day in the Southwest. A little warm during the day, but cool enough in the evenings and at night that you want to stick your arm out the window while driving. In doing so, you notice it's a lot cooler in the blink of an eye. What is the cause of this sudden change in temperature? Microclimates, and they're more common in our desert environment than you may think. Microclimates can be born with the simplest of variables.
If you get more heating in one area versus another, and also differences in the soil type.
Microclimates are areas inside the larger climate scale where the weather differs from the majority of the other areas.
What that can do is cause a differential heating, which in turn can lead to localized wind currents set up.
So where are some of these areas? For starters, looking at agriculture versus urban areas provides a hint.
In a process known as the urban heat island effect, areas with more asphalt and buildings tend to absorb the heat just a little bit better than others. Here at MCAS Yuma, where the official temperature is recorded, they have plenty of both. Playing a major role in our local ecosystem, the orchards and the soil moisture they contain can lower our temperature up to 15 degrees in just a matter of a few blocks. Perhaps the most major player in our ecosystem is that of our agriculture. And even though the soil doesn't contain any vegetation yet, the water that it contains really makes a difference when it comes to localized climates. As you can see, our temperature's still down from the official reporting station at MCAS, indicating that moisture and soil presence keeping the temperature down.
Despite the differences at the surface, there are more ways topography affects agriculture with differences in the weather.
What we're looking for are areas that are either high or low temperatures.
Yuma Agriculture Center Interim Director Dr. Kurt Nolte explains that an area's landscape and proximity to certain geographic features can change the temperature slightly or dramatically depending on the surrounding areas.
Those areas that are mostly affected by microclimates are those that are in close proximity to the river.
This becomes more substantial during the winter months when the winds switch from the south to the north on a consistent basis. One particular area, Dr. Nolte says, is the warmest spot in Yuma.
The warm air that's displaced in the valley tends to go up to the mesa, and in certain parts of the surrounding mesa can be a lot warmer than other areas.
So, why would a simple shift in winds make that much of a difference? Water takes much longer to cool than air, so the Colorado River is still plenty warm from the summer and fall months. This north breeze takes that warm air and displaces it over cooler spots, thus producing a warm zone for crop growth.
We also see a difference in the lower elevations where we have trees right along the Colorado River as opposed to the trees that are up on the mesa.
Dave Mansheim, president of Bard Valley Medjool Date Growers Association, says figuring this out isn't something that happened overnight.
The people, as you see them out this winter planting the fields and everything, they've gone off years of experience and data to know specifically what areas they want to plant first to have that crop come in on certain days when the market's ready for it.
And Dr. Nolte would agree.
Growers here in Yuma are very savvy about that. They've been around quite a bit and they have this all figured out.
However you look at it, both gentlemen agree. There are some big differences in localized climate that have an effect on crop production.
It's called the granddaddy of all dust storms, and the word haboob comes from the Arab word hab, meaning wind. Now, a haboob is an intense dust storm created by a downburst of strong winds generated from a thunderstorm. The fact there's plenty of open desert and sand dunes surrounding El Centro fuel to aid in the creation of these often biblical-looking storms. When it comes to Mother Nature, there's always a chance she could throw all of these ingredients into the perfect storm.
Setting is late spring. The calendar reads late June. After 2 of our driest months have come and gone, we've barely seen a cloud in the sky, let alone felt a drop of rain. But this day feels a little bit different. It's muggier outside. Big puffy clouds are starting to dominate the noon sky. You don't think much of it until you notice 30 minutes later, that same cloud looks quite a bit bigger. Something's brewing in the sky. Then you realize it's monsoon season. For many in our area, monsoon season provides us a time of excitement. Rain, lightning, and wind. grace us with their presence, whether directly or merely providing a scenic backdrop in the distance as we gaze into the desert sky. But every positive often draws a negative along with it. Flooding rain, wildfires caused by lightning, and damage from the wind. We saw a good example of the latter in early April when there were area-wide wind gusts of over 60 miles per hour, and those weren't even caused by a thunderstorm. This wasn't a haboob, but merely gusty winds from a very sharp pressure gradient. So could one of these thunderstorm-generated large-scale dust storms affect our area? I asked Warning Coordination Meteorologist Ken Waters of the National Weather Service office in Phoenix that very question.
They're not as common to have the really, really large-scale, really big ones there. It's more likely that Yuma's going to get ones that have been maybe traveling for a ways, like some that come from central Arizona, but you can still have them. The big key here is the source of dust. There's a greater source of dust actually in central and southern Arizona than what you have out in Yuma. For that reason, primarily, that's why you're less likely to get the really large storms, but they can be just as dangerous.
So I decided to test that out for myself as I set out towards Buttercup to collect some of this heavier sand for an experiment.
When we talk about these massive dust storms, or haboobs as they are often referred to, we see a big cloud of dust in the air. Now, what is that dust containing? Well, it starts with sand and many other dirt particles, and the size of the particles are what we refer to. It's a lighter sand, and you can see it just falls through my hands, which is one of the reasons that we see it pick up so well. This is the sand that's a little bit different than the one we see about 95% of the areas. Now, in the dunes, Glamis, Buttercup area specifically, we got this one from Buttercup. Now, looking at it right now, we can see just a little bit more coarse. As we take a closer up look, I'm going to put these in front of this fan, blowing very high, just a few miles an hour, nothing near what we would see from a thunderstorm, just to give you an idea of how differently these particles react when it comes to wind. First, the regular sand.
Notice with the typical sand, it's affected by the fan right away.
Now, this is the sand from the sand dunes.
The coarser sand doesn't move as easily until it's further from the jar.
Despite the different shapes and sizes to these elements that can be picked up by the wind, the bottom line is that haboobs are possible in our area, ranging from local areas to widespread and cross-state. Haboobs are absolutely an aspect of our local weather palette and should be taken very seriously. This one behind us, sent by Donna T. just today. This was a picture in El Centro from last year. So just a smaller scale one to the ones that we mentioned earlier that look more of a biblical scale. Only Mother Nature knows what's in store for this monsoon season, but we'll keep you up to date right here in the Skywarn Weather Lab. Reporting from the Newsplex, Chief Meteorologist Garry Frank, 13 on your side.